Court in session.
Your Honor, I wasn't speeding.
Prove it.
Well, I did some physics calculus.
Physics? What's physics?
Well, I'll take you through my work as I prove my innocence. The things we do know are that the speed limit was 45 miles per hour, I was braking for 20 meters, the mass of my car is 1,000 kilograms, the coefficient of friction is 0.7. Let me set the scene. I was driving along one day, under the speed limit might I add, when a biker rode out in front of me.
Oh, no!
I slammed on the brakes just in time. Here's some basic terms you'll need to know. Force causes a mass to speed up, slow down, or change direction. Friction is the force that creates resistance on the wheels from the ground that stops the car. Kinetic energy is what an object needs to have motion. Work is how much energy is used to apply a force over a distance. To start, I need to find the force of friction acting on my car. The force of friction acted on my car for 20 meters, creating these skid marks. I took the coefficient of friction, 0.7, which is the force of friction divided by the normal force on my car. The normal force is the force of the road holding up the weight of my car. The weight is mass times gravity. Otherwise, my car would fall through to China. I found the normal force, which is equal to the acceleration due to gravity, 9.8 meters per second squared, times the mass of my car, 1,000 kilograms. So the normal force was 9,800 newtons. To calculate the force of friction, I did the coefficient of friction times the normal force of my car, 0.7 times 9,800 to get 6,860 newtons. Then I had to find the work done by friction, which is me braking. So I did the force of friction, 6,860 newtons, times the 20 meters that it acted, and got 137,200 joules. Since friction is acting against my car, this is actually negative 137,200 joules. According to the law of conservation of energy, the total amount of energy remains constant in an isolated system, much like this one. Therefore, the work done by friction must be equal to the original kinetic energy of my car, 137,200 joules, and that would be positive because my car was moving forward. The equation for kinetic energy is 1/2 mass times velocity squared. In this case, we know that the mass of my car is 1,000 kilograms, and the kinetic energy must be 137,200 joules. Therefore, plugging in all these numbers, we can solve for the velocity, which is 16.565 meters per second. This number probably doesn't mean much to you, so let's convert it to miles per hour, which will make a lot more sense. There are 3,600 seconds in an hour and 1,609 meters in a mile. If you multiply 16.565 by 3,600 and then divide by 1,609, you will find that my speed was 37.055 miles per hour and I was not speeding.
Innocent. Court adjourned.